Hey Guildies, Fletch here. So today we're going to talk about test-driven development, we're going to talk about unit testing, and how test-driven development with unit testing leads to something called imperative shell functional core, or some people say functional core imperative shell. I like ISFC better because it sounds like an international standard versus FCIS, which sounds like a TV show, and I just don't like it. So we're going to be talking about that sort of stuff a little bit. I'm not going to start sharing my screen yet, but if I start acting like I'm pointing at code and I haven't started sharing my screen, then tell me like last time. Sometimes I forget things. So let's talk about, let me go here. What is test-driven development? So there's a misconception that test-driven development means you write unit tests prior to writing your code. In reality, test-driven development can also be aligned with a concept called shift left, which is it's a DevOps concept, or it's a QA, quality assurance concept. It's this concept that your QA team, or your team that is ensuring the quality of the system, the testers, that they're actually part of the team. I know it sounds crazy, but they're part of the team, the product development and QA, the PDQ team, the three amigos. And so they're up there at the front of the discussion. They're talking about acceptance criteria, they're reading the stories, they're giving estimates along with the team, and that these testers, which also might come to be called SDETs, software development engineers for testing, these testers write their tests up front. So they've got this thing called acceptance tests. They write their tests into some sort of an automated system that will automatically run whenever code is deployed. And they say, at the end of this requirement, at the end of this user story, or the end of this definition, with these acceptance criteria, we require that these tests will be able to pass. And they write the tests maybe before the developer even starts. That's unlikely. It's usually at the same time, or they can even start before the developer, but they need to finish before the developer finishes. It would be best if they finish before the developer finishes. And that's a completely different mindset from what a lot of people think when they hear about QA. They think the developer does all their stuff, and yeah, QA needs to understand what's going on, but we give them the requirement after the developer's done, and they read through it and they test it, as like a after development part. But test-driven development isn't an after development part. Test-driven development says, write the tests in whatever the external system is going to be. Write the test in Postman, for example, and finish those tests while the developers are working. And then you can also communicate back and forth, so the developers can help communicate, this is what the API endpoint is going to be, so Postman can hit it. Or this is, or maybe you're writing your tests from the user interface perspective. So you're writing these tests in Selenium, and they're going through the user interface, and the user interface is hitting some sort of HTTP service, which then goes up to the web API. And so the SDETs, or the QA, can go in there and they can write these tests that are hitting those things, and they need to know what the API endpoint is going to be, what kind of wrap parameters they need to be there, or what the contract is for that API endpoint, what the model needs to look like. And these are all things that can happen at the beginning of the requirements gathering. They can happen while the acceptance criteria are being written. They can happen with the communication between the developer and the QA person and the product person. And we can come up with this contract. So test-driven development is this big concept, and that's actually not what this talk is about. But there is a portion of test-driven development where the developer writes unit tests, which is a reserved term, I'm going to say. Unit testing is a reserved term specifically for the thing I'm about to be talking about. They write their unit tests, and then they write the portion of the code that is the business requirements, the business rules, the business logic, the BLL, whatever you want to call that portion of the system. Not the cross-cutting concerns, not the data repo. It's not the front boundary or the back boundary. It's that middle part that represents what this part of the service is all about, or what this service as a whole is all about. That's the business layer, or the business requirements. So, lots of different words for it. You write your tests, and then you code that piece of the thing. So that's test-driven development from the developer's perspective. Whereas TDD in general just says write tests before everything. So I just wanted to get that out of the way as the definition of TDD. And And now I'll go into what is integration testing. So integration testing is testing some part of code, some part of a system that also has dependencies on external factors. So if I want to test this piece of code and this piece of code hits a database, that's integration testing. Or I want to test this piece of code and this piece of code has an SDK that calls out to FedEx or some other system, that's integration testing. Because even if your main goal is to test the middle functional part, if you are at all hitting any parts of any other external systems that you don't control, it's an integration test. So integration test means there's two different kinds of integration tests as far as I'm concerned. There's dev integration tests, or what I'd end up calling schema testing. And schema testing is you write something like unit tests. It's part of the solution. It's in the code that gets committed to the same repository. And when these tests are run, all they're doing is making sure that our repo layer, our very back boundary, is expecting some sort of schema to exist for its third-party dependency. It's SQL Server or its file system or whatever it's hitting outside of that. So these dev integration tests or schema tests, they can either hit the database and say, give me back the schema, and then I'm going to check against it, make sure it's something that I have. Or you can actually call methods, like try to do an insert with the columns that you're expecting to be there, and then after that try to do a read and read back out those columns, make sure that the data is there. There's a lot of ways that you can do that. The goal is not to test your full repository, because there's going to be all kinds of logic in there that's going to be putting together your queries and whatever else. There might even be some functional logic in there. So there's going to be a lot of things in there. But the point of these integration tests is just to make sure that the schema matches what our repository layer is thinking, our back boundary of our system is expecting. The other type of integration testing, which is all of the rest of the integration testing, they're not things that are written into the code and checked into the solution. These are things that are written in other applications like Postman and Selenium, and these tests are going to be consuming our whole code base, configured the exact way that our whole code base is supposed to be configured, and it's going to be doing things like regression testing, performance testing, end-to-end testing. I'm not saying I promote all these things, but depending on your system, you may need to do all these different types of testing. And if you're automating these things, automated regression testing or acceptance testing, then those are also part of integration tests. Those are normal integration tests. They happen outside of the code, and they consume the code. They hit the system from the outside, and they're doing integration testing. There's a lot of different kinds of integration testing. So how do you do acceptance testing? So TDD acceptance testing, at the very beginning, when you're talking about acceptance criteria in your user requirements and your user story, or your whatever you want to call, whatever you use to plan all this functionality, the way that you do acceptance testing is you have the QA as actually part of the team, and they're in there looking at the acceptance criteria, maybe helping even tweak the acceptance criteria with product owns the acceptance criteria, so you can't just go in there and change whatever you want. But as part of the team with product QA and development, they review the acceptance criteria, and then from the acceptance criteria, they create like a one-to-many set of tests. So there could be 4 or 5 acceptance criteria, maybe 1 acceptance criteria. There shouldn't be thousands of acceptance criteria, otherwise this requirement is too big. But there's a few acceptance criteria that are highly cohesive to the functionality required for this requirement. and QA will, or QA or SDETs or whatever that team is for doing the testing, they'll take those acceptance criteria and they will write in these other systems like Selenium and Postman, they will write the tests in there. So one acceptance criteria, you could say, well, what if the input is null? What if the input is a billion? What if the input is not an email address? There's a lot of things that one acceptance criteria could have for inputs and outputs. So as long as that acceptance criteria is met, there's like a one-to-many relationship with each acceptance criteria. So there could be a lot of integration tests that come about from that. So that's how you do acceptance testing. You create those tests probably, hopefully, before the development is started, definitely before the development's finished. You create all of those tests, and then you run them in an automated fashion. You run them daily against production or against all of your environments. You definitely run them after a deploy and or after release. Deploying and releasing should be two separate things. It's a whole different discussion. So that's how you do acceptance testing, which is TDD. Now, what is unit testing? So at this point, we're done with the non-code, talking about all of the non-code related stuff. So let me go ahead and share my screen. I remembered to do it this time. Bam. Keep me on there. So TDD from the developer's perspective is called unit testing before you do the code. It's just a longer way to say TDD from the developer's perspective. So all the stuff I said before is TDD, the bigger picture TDD, which is about the whole system and about the teamwork and about agile principles. But this version, this part of TDD, just for the domain developer or the backend developer or the middle developer inside the UI, the person writing those services in JavaScript, the person doing the coding in a system should be doing TDD from their perspective, which means writing unit tests, which leads into writing good code. So I'm going to take this example from what I did in my last talk, and you don't have to pause and go look at my last talk right now. I'm going to break it down a little bit. But my last talk was essentially a payroll service, and there's a couple requirements. One of the requirements is to calculate, one of the things is that the rate that we're billing to clients is a certain rate. And so the rate that we pay our contractors who are working with those clients, they don't get paid the same exact rate, but it's pretty close. And there's some calculations that have to go in to find that out. So this is the contractor's rate, which is the rate, the client's rate, but after client withholding. So there's like some withholding that we hold back, and then we give it back to them at the end of the year or something like that. So we have all these tests. And so I'm going to, I sort of did this in a TDD type fashion before, but I'm going to sort of do a little bit more TDD in this way. We're going to say fact, very important backslash there. I'm just going to call this the same exact thing as this. Okay, so assuming, let me see here, get contractor rate. Okay, so we're going to assume that didn't happen. So we're going to say, first thing off the top of our head when we're doing TDD is that we want to come up with just a very basic scenario. We don't want to go for all of the bad cases, just one good case. So we're going to say var expected equals 90. So assuming we're paying var client rate equals 100. So assuming we're paying the client $100 an hour, and var withholding percent equals 10. But we're withholding 10% from the contractors. So we're expecting that the contractor should be getting paid $90 an hour. So with this, we're going to say var actual equals, let's see how it does before, payroll service dot this client rate withholding percent assert dot equal expected and actual. All right, and then of course, as the meme goes, run this and make sure it fails. Of course it's going to fail because this method doesn't exist. Let's go ahead and generate that method. Hopefully put it in the right place. It did not. That's fine. I can move it. Oh, it was in the right place. It was just at the bottom. I just didn't want it at the bottom. Let's put it at the top. All right, so now the method exists, and of course we run it and it'll fail. What we want to do is we want to make it pass. So we're going to do some TDD. We wrote a test. It definitely fails because even if I run it right now, it'll throw a not implemented exception. But let me actually do some implementation, and this implementation, I'm just going to do this right here. Decimal. And we've got, let's see, we call that UC. Oh, this isn't even the right thing. Bam. Bam. Client rate, completion withholding percent. There we go. Okay, so we do some TDD. I know that we already had that method, like I said before. We've done this already before, but let me just show this. So now we're returning client rate. This should find the inverse of whatever the 10% is. So the inverse of the 10 would be 90. So 90% of the client rate is what we should be paying to the contractor. So we'll go back to the tests, and we will say run all tests. Of course, we just need to run this one, but all right, cool. So we wrote a test. It was a very simple test. It's just like the happiest path we could possibly think of. we happen to be billing the client exactly $100 per hour, 10% nice round number of what we're withholding from the contractor. And so we're expecting the contractor to get $90 an hour. So super simple. We've done a TDD. A TDD is done. But we don't just want one of these. We want to try multiple. So now if we were to say, let's start by just making a whole nother thing. Happy path. And we'll call this one null. Null, say negative client rate, something like that. So for the client rate, we say negative 100. So if for some reason we get a negative, what are we expecting to happen? We need to come up with this prior to writing the code. We don't want to write the code and then see what the code gives back and be like, that's what we expected to happen, so I guess we'll just make the test say that that's the answer. We need to talk to product and our technical team and QA, and we need to say, why would we ever get this? Because the client rate comes from the database, and so how would that have happened? Maybe somebody went in a script and they fat fingered a script, or they inserted that in there because they have some idea of what's going to happen in the future, like some other implementation where they're expecting a negative rate. But as far as we're concerned here, negative shouldn't happen. We should never be billing the client a negative rate, and especially that this actually coming back would probably say that means that the time that our contractor is spending, we're taking money from them because it'll end up being negative. And so like none of this is going to turn out well. So what we're actually expecting to happen, hopefully, is something like assert dot. I don't want to go into throws and returning null. My whole last few videos, or many videos this year, we're talking about how we don't want to control our code flow with throws and throwing exceptions and nulls. So let's just not do that. So knowing that we're not just going to have a happy path, we're going to have possibly sad paths. Let's go back to this and let's change it from a decimal to a maybe decimal. And so let's say what we're expecting to happen. Well, first of all, now that we've changed the return type, actually we don't need to change the test because of the way that maybes work. We should still be able to say this. Run. It still works perfectly fine because of the way monads work. And so check out my other videos if you want to know about some of that stuff. So for this, what we're saying is we want to make sure that what comes back is a maybe.none, because this should not work. This should typically throw an exception or return null, but in this case we're going to say we're going to return maybe.none, which means we're not happy with what this is. Use this for your code flow, something that the non-happy path. So if we run this, of course it's going to fail because we didn't get back a maybe.none. We got back an actual thing. What did it actually return? No, actual is just has value. Okay, so what we want to do is say if client rate is less than or equal to 0, return maybe.none with a little message in here of type decimal, with a message in here that says client rate must be a positive integer greater than 0. That's probably not the same exact message as in my other one, but that's fine because we shouldn't be. This is a human readable message. We shouldn't be parsing off of this or using this for any of our code flow. Just the fact that we're returning maybe.none should be exactly what we're doing. So let's say run this. Cool. All right, we got 2 passing tests, and we should keep on with this pattern of test-driven development, writing unit tests, and then from the developer perspective, test-driven development, writing unit tests, doing code over and over until, let's go ahead and just clear this out, until you get to this. This. Okay, so this one, it had the same thing, it had a couple different conditions, and it had a lot of different possibilities, possible tests. I think it was this one. So right after right after the client withholding. So we have a lot of tests here. I mean, we could even have 100 tests here. We could have all kinds of different things. I think this pretty much covers it. We've got a negative value for the withholding percent. We've got a negative value for the client rate. We've got a lot of cool tests here. So we've written tests. We've written a lot of different theories. In this case, they're called theories. We've written a lot of different theories with this inline data. And And with each iteration, we then went into our implementation. We made little tweaks and changes until we eventually have this thing. So this is great. This is test-driven development. I don't think I'm teaching anyone necessarily anything new here, but the next thing is the important thing. What we're doing here is, with our tests anyway, I mean, this is all great, but we're passing it in the client rate. We're telling it the client rate's 200, the client rate is 150. We're just telling it what the client rate is. In reality, that client rate's supposed to come from a database. So one thing that some people would do, which you should definitely not do, is say, okay, well, we've written our test-driven development. We've got some test cases here. Okay, now what's the next thing I need to do? Before I do that, just so I can keep things clear, I'm going to say changes. All that really was ended up being like a method rename. So what a lot of people do is they say, okay, but we actually need to get this client rate from the database. So there's a couple different ways we can do this. First of all, let's think about this from the database perspective. And we're going to say, let me move this down so that this one's at the top. So we're going to say this class needs to have a constructor with a client repo, and I wonder if it'll, let me do this here. Yeah, sure, why not? We need to have this repo here. The reason why I didn't show up the thing here is because we actually have this as a partial class, and it's over here. Let's go ahead and do like this for now. This is going to cause all kinds of issues, but just to sort of demonstrate what this looks like here. I thought I changed that. So they say, okay, well, we're going to need the repo in here, and instead of just having the client rate be passed in, what we need to do is maybe say int client ID. So what we really need to know is the client ID, and we're going to say var client rate equals repo dot get client by client ID. This is probably going to be dot rate. For now, I'm going to do this just as an example. Okay, so we've got the client. So now instead of accepting a rate, we're going to accept the client ID, and we got the client. And that's going to mean, and this is actually this is the picture that's for the thumbnail for this video. Don't do this. So now instead of getting the client rate just passed into us, because what really is going to happen is we're going to have to get this from the database. So now what we're going to have to do is go back to our tests as an example. If it's not clear, I'm showing you what not to do. We're going to go back to our test and we're say, instead of these, I'm going to go ahead and keep these as 100 because I'm going to use the ID as the client rate. But I'm going to say, let's mock out var mock repo equals new mock repo. And mock repo is going to be a class that implements public class mock repo I payroll repo. One second. iClient repo. iClient repo. Int ID and rate, and then we want this as a field, and we actually want it to be like this, and we're going to implement this, and we're going to say return ID and rate. I actually want to do a task.fromResult ID and rate, and bam. Oh. Oh, client and entity. Okay. New client entity with ID equals this and rate equals this. Okay. Oh, cool. So we've done a mock-out. And again, I'm saying don't do this. This is something that you shouldn't be doing, but a lot of people end up doing this. In order to fulfill our test, we end up having to create a repo, and we're going to put the client rate inside here. So we had to make a repo. We had to mock out the repo, and now this will work. Let's say mock. Oh, okay. Var system under test. Something that I hate to have to say. New payroll service X with the mock repo. I know this is a lot of work. So we're going to say the rate is system under test dot rate after client withholding, and we're going to use client rate because remember the ID and the rate are the same thing because that's just what we're doing here for this test. Now this should end up passing, and that's great that this will end up passing. Let me just double check that this will end up passing. Let's just say we do run. Of course, I'm not going to be able to run this because since I renamed everything, there's a lot of errors with my other services. I wonder if I can do this. Payroll service Y, rate after client withholding. I actually want to see that this ends up passing. Let's do this. Payroll service X dot. Yeah, this is going to get too messy. But the whole point is that, look, we can do this. We can write system unit tests and do test-driven development, write unit tests, and then end up creating functional code that looks really beautiful. And then once we decide, okay, now we want to integrate with the database, we can change our functional code, and we could say, well, instead let's pass in IDs, and let's call the repo here. And then maybe somewhere else down here we're calling the repo again, and maybe we get some value, and then like we save to the repo, and then we return some ID or something like that. We can definitely do that. But what I'm saying is you went from a beautiful test-driven development, you wrote your tests, you wrote some functional code, and then you went and ruined it by changing your beautiful functional code to be impure and start hitting the database. So let's go back and take a look at the correct method. Undo those changes. I'm sorry if you joined late and you missed the beginning. So all that don't do this probably didn't make sense. So go back to the beginning here, and we've got the rate after client withholding method, which is now back at the bottom, of course. Okay, so we've got this method. It's pure still, and we've got the tests, and the tests are pure still. Much simpler tests. You don't need mocks or anything like that. The next step the next step that you need to do, once you do your test-driven development, you've written all of the requirements that are required inside of your business layer, your business logic layer, business requirements, that all of that code that you've written, where you've written all of the functional code required, all you're missing now is the impure stuff, the stuff where you need to pull something from the database or save something to the database, the stuff that you need to return back to the API so the client can return. You don't touch this. You leave this alone. Let your tests continue to pass, and what you do is you create the imperative shell. You create this shell around it where you say, I know I have a bunch of functional methods, but what I need to do is compose up some sort of functionality that says I have all these functional methods, and I also need to compose these together with a call to a database or a read or a write or any sort of CRUD. I need to work with the database a little bit, and I need to compose these things together to get what I really want my final result to be. So the way that you compose those things together is by doing something here inside of the imperative shell. So the imperative shell is the portion of the class or the class, just the service that implements the interface. And the reason it's the thing that implements the interface is because one of the big reasons why we use interfaces isn't only so that we can create multiple different implementations of that interface, but so that these things become mockable or testable or removable by anyone who wants to be able to do that sort of thing. Granted, we're not actually mocking any of this stuff out, because that's part of what I'm getting into, is that we shouldn't have to do that. But what we have here is the imperative shell. This is the service that is going to compose together all of our functional code along with calls to a database. And so I went over exactly what all this is doing in my last video, but I'll touch on it a little bit. We've got a call to a database. We're binding to that. We're binding this client that comes back from here. We're binding it like this. We're binding that client with the maybe monad, and we're saying with this client, we want to do these things. And so we have this rate after client withholding. That's literally the method we were just talking about. And we're saying we want to bind the result of this, which could very well, like I said before, could return a maybe not none, or an unhappy value, in other words. And so we want to bind this rate to these things. And so we're going to try to get the client weekly pay. And the client weekly pay is assuming 40 hours a week with this rate that we just bound to. We want to try to get the client weekly pay, which is the total amount for the week. And we want to bind the usage of that to these things. And so it just sort of nests in more and more binding. So we're binding together these things, and we're binding them with the repo. And if in one of my other videos I talk about guard clauses. And what guard clauses essentially say is, okay, we're going to call the repo. Well, if the value was null, the client that came back was null, then cut out of here. We're going to guard against doing any more things. We're going to cut out of here. Or if you have that in a try catch, if it threw an exception, then let's cut out of here. Let's not do anything else any further. And that's exactly what a bind is doing. A bind is like a guard clause. .guard would actually probably be a very apt name for this. So we have the repo.get client. We're saying bind such that if it's a positive value, so not null, not throwing an exception, not anything like that, if it's a positive value, then continue on with these things. If the repo.get client were to return a negative value, a negative monad, otherwise known as maybe.none, if it were to return a maybe.none, then it would just cut out right here. It would say, okay, bind, you want to bind to a positive value. We don't have a positive value. We do have a maybe.none with some exception information or a human readable message or whatever. So we do have that. So what we're going to do, instead of continuing on, we're going to cut out right here, just like a guard clause would. We're going to cut out, and we're going to return back a maybe.none. Because we hit a point where we had a maybe.none, that maybe.none was a maybe of type client entity, because we're trying to hit the database and get back a client entity. And what we're returning back here is a list of paychecks, a maybe of list of paychecks. So we're going to take that maybe of type client entity, and we're going to say there wasn't a client entity, or there was some exception that was thrown whenever we tried to, a network exception or something. So there was a maybe.none. So we're going to say return that maybe.none, but cast as a list of paycheck model. So we're going to return that maybe.none from the client entity as a maybe.none of a list of paycheck. You don't need to do any sort of conversion from a client entity to a list of paycheck because there's nothing there. It's a maybe.none. There is no client entity in this. There is possibly exception information or a human readable message, maybe some other state depending on which implementation of a maybe monad that you're using. So there is some information unrelated to a client entity, unrelated to any specific type, so that maybe.none does not need to do a conversion from client entity to list of paycheck model. All we're returning is a maybe.none with that additional information. So we're going to do the guard clause here. We're going to check this, and we're maybe do a guard clause here. We're going to do maybe a guard clause here. So we're going to do all those guard clauses. And the reason why I'm talking about guard clauses is because you don't need to unit test guard clauses. Guard clauses are, what you need to test is conditional transformations, and guard clauses, they're conditional because, like, if something's null, just return back, just return null or something. But they're not conditional transformations. They're conditionals that are guarding against continuing on. It's just saying, let's cut out of here and let's just stop, do nothing. Don't do any more transformations, just return null, or just return what we've got, just stop right here. So guard clause, guard clause, guard clause. There's no functionality in here. All of the functionality is listed inside this, inside this, inside this method. All of these methods have functionality in them, and they're all already unit tested. I mean, you can look over here on the side. We've got unit tests out the wazoo over here. This method is considered tested as far as unit testing goes. So, so what we have now is a functional core, and I'm not saying you have to name folders this. You don't have to use partial classes. You can do this with helper classes or however you want to do it. But you have your functional core, which was developed by doing developer test-driven development. That's the unit testing, write unit tests, do test-driven development. And then once you realize, okay, but now I need to interact with a database or a file system or a website, website parsing or whatever the thing is that you're doing, once you realize you get to that point, then you need to wrap this functionality, all these business requirements and business rules that you've programmed in here, all these algorithms, you need to wrap them in an imperative shell. And that imperative shell will take the repository, talk to the database, and it'll compose together all of this functionality exactly how you have it. And once you're done writing this imperative shell, you run your tests. And since you didn't change anything in your functional core, all your tests pass. You haven't broken anything as far as unit testing goes. But the way that you test this, because composing this together obviously has different paths it can take, the different ways that it could return maybe .none instead of getting through everything correctly. Not only that, but what if you don't have good configuration for your database? You want to test to make sure that this function works. But as I said during the whole beginning part of this talk, test-driven development is about writing tests to test your system before doing the development, and this is not tested by doing unit testing. This part is tested by those tests that were written by the SDETs, or you if you're wearing the SDET hat, or QA, or the testing group, whatever that group is called. They've written those tests in, let's just say Postman. Let's say they've written the tests in Postman. So you've done everything that you need to do here. You've written all your functional core, you've written your imperative shell, and you also happen to have written your endpoint. Another part that I was saying in the beginning of this talk, in case you came in late, is that the first thing that you do whenever you're talking to your testers, you're talking to product, you're looking at the acceptance criteria of a requirement or user story. You're looking at all that stuff together, and you're communicating with the person who's going to be writing these integration tests. You're communicating with them, okay, well, let's agree that what you need to send me, you need to hit this endpoint with these route parameters. Send me the client ID. I'll make sure that that gets worked into my code. Send me some DTO with some properties on it. So, send me some JSON inside the body with monthly benefits, for example. And I didn't get into the whole calculation of all this functional code, but maybe you need more than this. Maybe you need a few different things on there. And so you talk about this contract, this API contract with the UI developer or the SDET, whoever's working with that stuff. So now that you've finished your developer test-driven development, writing unit tests and doing your building up your functional core, and you've also finished your imperative shell, and you have previously finished, based on those conversations, writing up your contract for the API. Now what you can do is you can commit your code, and when you commit your code and you have CI/CD and it automatically integrates and automatically deploys, and you have your deployments and or your releases trigger an automated test, that automated test, that test that they've written, will either fail or pass, I guess, in that case. In this case, it would probably pass because we had a lot of good communication up front. We were all part of a team. But the way that we ended up writing our code here is functional code, imperative shell. That's just how test-driven development with unit testing ends up working. Unless, as I pointed out right there in the middle, unless when you're done with your functional core, you say, all right, now we need a database, and then you just completely destroy all your code and start injecting all these dependencies and such. If you want to completely destroy your code like that, then you can. But if you do test-driven development and you keep your code clean and you wrap an imperative shell around it, your code just naturally becomes imperative shell functional core.